to a real life situation. Now, this is a little bit of a stretch for a real life situation, given as it is presented. It could certainly be given in a more serious situation where this could be more important, but we are talking about a rowboat in the ocean, so a boat on the ocean is 4 miles from the nearest point on a straight shoreline. The point is 6 miles from a restaurant on the shore. A woman plans to row the boat straight to a point on the shore and then walk along the shore to the restaurant. If she walks at 3 miles per hour and rows at 2 miles per hour, at which point on the shore should she land to minimize the total travel time? Okay, so first of all, we have a straight shoreline. So here's our shoreline here. And we have a crazy woman out here with her paddles, who is in a rowboat 4 miles from the shore in the ocean. That's a long ways to be out there in a rowboat. But she is 4 miles from shore. So that is the distance from her to the shore. And that point is 6 miles from this restaurant that she wants to eat at down the way. So if this woman, so let's think about, we're going to do this a little bit like we did the other day. I'm going to lock this in place, and you don't even necessarily have to write this down. Let's think about the two extreme scenarios here. Let's see, lock in place. All right, so what would be the shortest distance for her to go to that restaurant? Just the diagonal, right? So the shortest distance for her to go to the restaurant is just diagonal right here. So if she did this, if she just went diagonal, how would we figure out that length? Just you could use, well, just Pythagorean theorem here. Yeah, I don't think you could even use trig because we don't have an angle. Or you make it way more complicated if you did. So so you would just do 4 squared plus 6 squared equals your x squared, and that would be 16 plus 36, which would give you 52 is your x squared, and if we do square root of 52, we're going to get 7.211. I think it's the one repeating. Maybe not. It's the square root. It's probably not repeating. 0.2111 is your distance here. Now, here's the thing. She can only row at 2 miles per hour. How long is it going to take her to row to that restaurant? How would we figure that out? No. She can go 2 miles every hour. Divide it by 2. So 7.2111 miles divided by 2 miles per hour is going to give us 3.60555 hours. So that's the scenario where she just goes shortest distance. That's definitely going to be the shortest distance, but she can walk faster than she can row on the in the situation. So let's think of the other extreme situation. All right, she could row directly to shore and then walk to the restaurant. That's going to be the furthest distance she could possibly go. But she can row I mean, she can walk faster. So let's see if we've got, she's going to row for 4 miles. So 4 divided by 2. It's a choppy ocean.
It's choppy.
Yeah, this is not smooth water. This is not smooth water. She's leisurely walking along the beach. And it's harder to walk in the sand than it is on pavement. She's rowing and it's choppy. And there's sharks circling around her rowboat, so she's scared. Actually, that might make you go faster. And she might be an old lady. Possibly.
She could be paddleboarding and try not to fall off.
Could be. She could be paddleboarding, falling into shark-infested waters, and having to get back on every little bit. I don't know why you're questioning this perfectly plausible situation here, Troy. All right, so she can walk she has to walk for 6 miles, but she can do that at 3 miles per hour, right? So we would have to divide here. So that would be 2 plus 2. That would take her 4 hours. So it would be a little bit longer to do that if she rowed straight to shore and walked along the beach. So those are kind of like our 2 extremes here. However, more than likely, there is a third option that is going to be the most efficient. So that third option that is possibly going to be most efficient is for her to row somewhere along here and then walk the rest of the way. All right, so if we're looking at that green line right there, I need to know, basically I'm going to call this like A and B right here. I need to know those 2 distances. And let's call, I've already used the X. Let's call this like Y right here. This little distance right here is Y. So, I need to know the distance of A right here. How would I find that? I'm not going to be able to find it as like a whole number. It'll be an equation. This is a right angle, so you can do Pythagorean theorem here. You'll have 4 squared plus y squared equals that a squared. And I could square root both sides. So the square root of 16 plus y squared would be this piece right here. So I'm going to erase the a that I put right there. And I'm going to put this piece right here is square root of 16 plus y squared. It would have to be 16 plus y squared, because you cannot square root, like if I have square root of 9 plus 1, that is the square root of 10. It is not 3 plus 1, which is 4. So you cannot, with plus or minus signs, you can't square root each one. If it was multiplied, you could do that. It's like 4 squared times y squared. You could just say it was 4y. Okay, so that's this distance right here. I also need to know b. And since I've got a y here, it'd be good if my b was in terms of y also. Elementary school's calling me. Answer that. See if you can figure something out on. Hello. They had a practice lockdown drill at the elementary school and I wanted us to know about it. I thought Henry was sick. Every time I see the elementary school pop up. Sometimes it's on here and it's the nurse at the elementary school, and then I definitely know it's not good.
Have you ever gotten in a fight at school?
I've never got a call for a fight, but I think you got in trouble on the bus one time. I got a call for that one. So Huh? It wasn't a fight. He was just getting in trouble. He was being wild on the bus. So, yeah. No. Hopefully, we won't have any fights to worry about. Hunter has recently watched all of Cobra Kai, so that is not good for the possibilities of what's happening in the future. Henry told me, Mama, you got to quit letting him watch that show. He's going to beat me up. All right. Okay, what's the length of B? We can do B plus Y equals 6. So if we solve that for B, what will we get? 6 minus Y, right? Because the whole thing is 6, and we're subtracting this. So instead of writing that B, let's put that is 6 minus Y. Okay, so we're not just concerned with distance, though, because if we just want shortest distance, we'd just go diagonal, right? We care about the time. So if we write an equation for our time here, we need our distance rowing. Our distance rowing is square root of 16 plus y squared, and we have to divide that by 2 because she is rowing at 2 miles per hour. And then we would have to have our distance walking, which is 6 minus y. We would have to divide that by 3 because she's walking at 3 miles per hour. It will probably be a little easier to deal with this if we write it this way. 1/2 16 plus y squared to the 1/2 power. And then if I could also do love connection right here so that I don't end up with a fraction there. And that would just be plus 2 minus 1/3 y. All right, questions? All right, so we need to take the derivative of this, and then we may employ the use of our calculator, but we'll see how bad it gets. So we would do t prime equals, we're going to get 1/4 16 plus y squared to the negative 1/2 times the derivative of the inside. What's the derivative of the inside? 2y. What's the derivative of the 2? 0. It goes away. Derivative of 1/3 y? 1/3. Negative 1/3. So if we clean this up just a little bit, we're going to have that 2y is like it's over 1. So the 1/4 and the 2y could give us y over 2. And then we could send this back down to the bottom. We got square root of 16 plus y squared minus 1/3. Yeah, I think we're going to use our calculator from here. It could be done, but it's not going to be much fun. So we're going to set that equal to 0. We are going to grab the calculator for that. And hopefully it will solve it for us here. So solve. We're going to do y divided by, you need a set of parentheses here, 2 square root of 16 plus y squared. I got, how many parentheses have I got? Minus 1/3 equals 0, comma y. All right, cross your fingers that we got it in right. Ugh, green button in her. Because we would write. right, so we get 3.5771. So we get y equals 3.5771 for that. And then if we want to check, like if we plug in something smaller than 3, like 1, we'd get 1 over 2 times, like square root of 17. That's going to be a really small, it's going to be smaller than 1/3. So you'll get a negative, and then if you plug in something bigger, like 5, you'll probably get a positive, I think, for that, maybe. Hopefully. That should be our minimum right there. The best way for her to do this is to row to a point that is 3.5771 miles from the point right here, and then walk the rest of the way. So if you want to know like how much time that would take, because I am interested in how much time this is going to save us, it would be like we would plug it back into this equation. So we would have t equals square root of 16 plus 3.5771 squared divided by 2 plus 6 minus 3.5771 divided by 3. And if we do that in the calculator, there are, squeeze another 7 in there. We would have square root of square root, oh, no, I've got square root, sorry. All right, 16 plus answer squared, no. Divided by 2 plus 6 minus the answer divided by 3. Let's see if this looks right. All right, I got 3.49071 hours. That's my, actually the answer is this, I guess, but 3.49. So it would take 3.605, so 3.605 minus the answer that we just got. It is going to save us 0.11 hours, which is 6.6 minutes. So it would be 6.6 minutes quicker if she did this. It's taken us 18 minutes to solve the problem. So, yeah. So this is clearly like a textbook problem. It is not a real world necessarily example. However, this closely mirrors number 39 in your book. And here, for the rest of the class, you guys are going to work on your assignment for